Hello, in this video we will find the value of DE. In the drawing we have triangle ABC. We know that this side AC of the triangle equals to 2 units. Side BC of the triangle equals to 8 units. We also know that line segment DE is parallel to side AB of the triangle. DE is parallel to AB. And we also know that DE, the size of DE is a number that belongs to the natural numbers. And we also know that this point G, is the centroid of triangle ABC. So what is centroid? Centroid of any triangle is a point in which the three medians of the triangle intersect with each other. Okay? And we want to find out the value of DE, or the size of DE. And we know that DE is a natural number. The size of DE is a natural number. So, first of all, we have a rule that relates to centroid of a triangle. In any triangle, so if we have triangle ABC, that could be any triangle, and we know that AD is the median to BC. That is to say, AD bisects side BC, or AD divides BC to two equal parts. That is to say, BD equals to DC, and we also know that point G is the centroid of the triangle. That is to say, at point G, the three medians of this triangle intersect with each other. Then the centroid G divides the median AD in a relationship that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Or in other words, AG is 2 times larger than GD. That is to say, AG equals 2 times GD. Okay, so if we define AG as 2x, that is to say, if AG equals to 2x according to our definition, then we can substitute AD in this equality by 2x, and we will get that 2x equals to 2 times GD. We substituted AG by 2x because AG equals to 2x. We will divide this equality by 2, and we will get that GD equals to x. So we found out that if AG equals to 2x, then GD will be equal to x. So AG equals to 2x and GD equals to x. Okay, so we can implement the rule, this rule, in our drawing, because in our drawing we have G that is the centroid of triangle ABC. So if CG equals to 2x, then GF will be equal to x, because CG is 2 times GF. So if CG equals to 2x, then CG will be equal to x, according to what we saw here. If AG is 2x, then GD is x. So here, if CG equals to 2x, then GF will be equal to x. And we also have a second rule that is also applied in any triangle. In any triangle, again, if we have triangle ABC, that can be any triangle, if we have triangle ABC, that could be any triangle, and we know that DE is parallel to BC. If DE is parallel to BC, then according to this rule, AD over DB will be equal to AE over EC. And this rule is true for any triangle. Again, if we have triangle ABC, that can be any triangle, and we know that DE is parallel to BC, then the following relationship exists between the sides of this triangle. AD over DB equals to AE over EC. And again, we can implement this, the second rule, in our drawing, because we know it is given us in the question that DE is parallel to AB. DE is parallel to AB. Therefore, according to the second rule, if we relate to triangle CAF, in triangle CAF, we know that DE is parallel to AE. Therefore, according to the second rule, CD over AD will be equal to CG over GF. Again, according to the second rule, if we relate to triangle CAF, we know that DE is parallel to AF. Therefore, according to the second rule, CD over AD will be equal to CG over GF. In triangle CAF, we know that DE is parallel to AB, therefore CD over AD equals to CG over GF. But what is the value of CG? The value of CG is 2x. And the value of GF is x. So we have here CD over AD equals to 2x over x. 2x over x is 2 because x over x is 1, so x will get cancelled, and we will get that CD over AD equals to 2. CD over AD equals to 2. And if we multiply this equality by 2, we will get that CD equals to 2 times AD. And again, if we define CD as 2y, if CD equals to 2y according to our definition, so we will substitute CD by 2y in this equality, and we will get that 2y equals to 2 times AD. 2y equals to 2 times AD, then we will divide this equality by 2, and we will get that AD equals to y. So we found out that if CD equals to 2y, then AD will be equal to y. Okay, again, we found out that if CD equals to 2y, then AD will be equal to y. So here we can write that CD equals to 2y, then AD will be equal to y. Okay? And we actually have another rule that states that corresponding angles between parallel lines are equal to each other. Okay, I will write it down. The rule states that corresponding angles between parallel lines are equal to each other. So I will read the rule again. The rule states that corresponding angles between parallel lines are equal to each other. And again, we can implement this rule in our drawing because we know that DE is parallel to AB. So we have two lines that are parallel to each other. That is to say, DE is parallel to AB, and according to this rule, that corresponding angles between parallel lines are equal to each other, we know that DE is parallel to AB, therefore the two corresponding angles, these two corresponding angles will be equal to each other. Okay, so this angle will be equal to this angle, so if this angle is alpha, then this angle will be also equal to alpha because of the fact that those two corresponding angles are located between parallel lines, that is to say DE is parallel to AB, therefore those two corresponding angles are equal to each other, that is to say they are both will be equal to alpha. Okay, so we write it down that angle BAC, this angle will be equal to angle CDB, this angle, and if one of the angles is equal to alpha, then the other angle will be also equal to alpha. Okay, so according to this rule, angle BAC will be equal to angle CDB, and both of the angles are equal to alpha. And for the same reason, we have another corresponding angles that are located between parallel lines. Those two corresponding angles are located between the two parallel lines, DE and AB. Therefore, they will be equal to each other. That is to say, angle CBA will be this angle will be equal to angle CED will be equal to this angle. Those two angles are located between parallel lines, therefore they are equal to each other according to this rule. And if one of the angles equals to beta, then the other angle will be also equal to beta. Okay, so angle CBA equals to angle CED equals to beta. Okay, again, those two angles are corresponding angles that are located between parallel lines, therefore they are equal to each other. That is to say, both of the angles are equal to beta. Okay, so those two angles are equal to each other and they are both equal to alpha, and those two angles are also equal to each other and they are both equal to beta, according to the rule that corresponding angles between parallel lines are equal to each other. So in the next step we will focus on triangle ABC and on triangle CDE. Okay, so in triangle ABC and triangle CDE, so we will focus on the big triangle, triangle ABC, and on the small triangle, triangle CDE, this triangle. Okay, we will focus on triangles ABC and CDE. On those two triangles, we know that angle CDE in triangle CDE is equal to angle CAB on triangle ABC, and they are both equal to alpha. So I will write it down. Angle CDE is equal to angle CAB, and they are both equal to alpha, as you can see from the drawing. Those two angles are equal to each other and they are both equal to alpha. So angle CDE on triangle CDE is equal to angle CAB on triangle ABC, and they are both equal to alpha. And we also know that angle CED on triangle CDE is equal to angle CBA on triangle ABC, and both angles are equal to beta. So I write it down. Angle CED is equal to angle CBA, and both angles are equal to beta. Okay, angle CED equals to angle CBA, and both angles are equal to beta. And the third angle, this angle is a common angle. it belongs to both triangles, to triangle ABC and to triangle CDE. So we can write down that angle C equals to angle C. It is a common angle. Angle C equals to angle C. It's a common angle. Okay, angle C equals to angle C. It is a common angle. It is a common angle. It belongs to both triangles. So we actually proved that all the angles of triangle ABC are equal to all the angles of triangle CDE. Therefore, we actually proved that triangle ABC is similar to triangle CDE according to angle similarity rule. So I write it down. Triangle ABC is similar, that is the sign of similar, to triangle CDE according to angle similarity rule. Again, triangle ABC is similar to triangle CDE according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is a rule that says that if you prove that all the angles of one triangle are equal to the angles of the other triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay? So, from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC is equal to DE over AB. Again, because of the fact that triangle ABC is similar to triangle CDE, we can conclude that this relationship exists between the sides of the similar triangle. That is to say, CD over AC equals to BD over AB. CD over AC equals to DE over AB. Okay? But what is the value of CD? CD equals to 2y. CD equals to 2y. And what is the value of AC? AC is CD plus AD. CD plus AD is 2y plus y. That is to say, 2y plus y equals to 3y. So we found out that DE over AB equals to 2y over 3y. Y over y is 1, so y will get cancelled. And we found out actually that DE over AB equals to 2 over 3. DE over AB equals to 2 over 3. Y will get cancelled here. 2 over 3. Here we will multiply this equality by AB and we will get that DE equals 2/3 AB. So we actually found out that DE is 2/3 of AB. DE is 2/3 of AB. And we actually have another rule that is true in any triangle. In any triangle, if we have triangle ABC, that can be any triangle, and we know that the size of side AB is A units, the size of side AC is B units, and the size of side BC of triangle ABC is C units. Then we actually have a rule that states that the sum of two sides of a triangle is always greater than the length of the third side, of the sum or the length of the sum of two sides of the triangle is always greater than the length of the third side. That is to say, if we relate to BC that the size of BC is C, the size C is smaller than the length of those two sides, that is to say, is smaller than A plus B. And we also know that the difference between two sides of a triangle, the difference between the lengths of two sides of a triangle is always smaller than the size of the third side. That is to say, C is greater than A minus B, or the absolute value of A minus B. Okay? Again, the meaning of this rule is that the sum of the length of two sides of a triangle is always greater than the third side, or it is always greater than the length of the third side, and the difference between two sides of a triangle is always smaller than the length of the third side. Okay? So we actually can implement this rule in our triangle ABC. If we relate to CB, if we relate to AB, AB will be smaller than AC plus CB, and side AB of triangle ABC will be greater in its size from the difference between CA and CB, or from the absolute value of the difference between CA and CB. So actually, this expression is the implementation of this rule in our drawing. That is to say, the size of AB is smaller than AC plus CB, and it is greater than the absolute value of CA minus CB. Okay? But we know that CA equals to 2 units and CB equals to 8 units, so we can write down that 2 minus 8, the absolute value, is smaller than AB. Okay, So CA equals to 2 units, CB equals to 8 units. So AB is greater than the absolute value of minus 6, and it is smaller than 10. So what is the absolute value? The absolute value of a number is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. So we'll get that AB is greater than 6 and it is smaller from 10. Okay? But we have already found out that DE equals to 2/3 AB. DE equals to 2/3 AB. So we will multiply this inequality by 2/3, and we will get that 2/3 AB smaller than 2/3 times 10, and it is greater than 2/3 times 6. And we know that 2/3 AB is actually DE, so we can substitute 2/3 AB by DE, and we will get that DE is greater than 2 times 6 is 12, 12 over 3 is 4, DE is greater than 4, and it is smaller than 2 times 10 is 20, and 20 over 3 is 6.66. Okay, so we found out that DE is greater than 4 and it is smaller than 6.66. But we also know it is giving us the question that DE belongs to the natural numbers. That is to say, DE is a natural number. DE is a natural number. It is given us in the question. We know that DE is a natural number because it belongs to the natural numbers. So which numbers we have, which natural numbers we have that are greater than 4 and that are smaller than 6.66? The only two natural numbers that are greater than 4 and smaller than 6.66 are 5 and 6. So we actually found out that DE equals to either 5 units or 6 units. Okay, so we found out that the value of DE is either 5 units or 6 units. That is to say, the size of this 9-segment DE is either 5 units or 6 units. That is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the value of DE. We know that DE is a natural number, and we also know that in triangle ABC, AC is 2 units, and side CB of triangle ABC is 8 units, and we know that DE is parallel to AB, and we want to find out the size of DE or the value of DE. So in order to find out the value of DE, we actually also know another thing, that G is the centroid of triangle ABC. And what is the centroid of any triangle? The centroid of any triangle is a point in which all the three medians of the triangle intersect with each other. Okay, G is a point where the three medians of the triangle intersect with each other. And we have a rule that relates to the median of any triangle. This triangle ABC can be any triangle, and we know that AD is the median of the triangle, that is to say it bisects BC, that is to say it divides BC to two equal parts, that is to say BD equals to DC. Then, according to this rule, the median G divides the centroid G. The centroid G divides the median AD in a relationship that equals to 2 and 1. Again, the centroid G of triangle ABC divides the median AD in a relationship that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Okay, if AG equals to 2 units, then GD will be equal to 2 units. So, in other words, AG is twice as large as GD. AG is twice as large as GD. Or in other words, AG equals to 2 times GD. Okay? And if we define AG as 2x, then, and so we substitute AD in this equality by 2x, because AG equals to 2x, and we'll get that 2x equals to 2 times GD. So we divide this equality by 2, and we'll get that GD equals to x. So we found out that if AG equals to 2x, then GD equals to x. Okay? So we can implement this rule in our triangle, because we have the median G of triangle ABC, and we have the centroid G. We have the centroid G of triangle ABC, and we have the median CF. We have the median CF, and according to the rule that I stated, the centroid G divides the median CF in a relationship to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. Or CG is twice as large as GF. Or in other words, if CG equals to 2x, then GF will be equal to x, because CG is twice as large as GF. Okay? So we found out that if CG equals to 2x, then GF will be equal to x. Then we have another rule, the second rule, that is, it is true in any triangle. In any triangle, if we know that DE is parallel to BC, then AD over DB will be equal to AE over EC. Again, in triangle ABC, that can be any triangle. If we know that line segment DE is parallel to side BC of the triangle, then AD over DB will be equal to AE over EC. Okay, and again we can implement the second rule in our triangle, because in our triangle, in our drawing, because we know that in our drawing DE is parallel to AB. It is given us in the question. DE is parallel to AB. So according to the rule that is stated, if we relate to triangle ACF, we know that DE is parallel to AB. If we relate to triangle ACF, then CD over AC will be equal, CD over AD will be equal to CG over GF. Okay, if we relate to triangle ACF, CD over AD will be equal to CG over GF. If we relate to triangle ACF, CD over AD will be equal to CG over GF according to this rule. According to this rule, because of the fact that DE is parallel to AB, if we relate to triangle ACF, then CD over AD will be equal to CG over GF. And but what is the value of CG? CG equals to 2x and GF equals to x. So we can write here that CG equals to 2x and GF equals to x. 2x over x is 2 because x over x is 1. So x will get cancelled and we will get that CD over AD equals to 2. And if we multiply this equality by AD, we will get that CD equals to 2 times AD. CD equals to 2 times AD. And if we define CD as 2y, so we'll substitute CD by 2y and we will get that 2y equals to 2 times AD. Then we will divide this equality by 2 and we will get that AD equals to y. So we actually found out that if CD equals to 2y, then AD equals to y. So here, if CD equals to 2y, then AD will be equal to y. Okay? Then we have the rule that states that corresponding angles between parallel lines are equal to each other. So we can implement this rule in our drawing because we know that in our drawing line DE is parallel to line AB. DE is parallel to AB. Therefore, according to this rule, the corresponding angles that are located between the parallel lines DE and AB will be equal to each other. Those two angles are corresponding angles and they are located between parallel lines, therefore they will be equal to each other. That is to say, angle BAC will be equal to angle CDB will be equal to alpha, according to this rule. And the same thing is true in the other side of the triangle. We know that DE is parallel to AB, therefore the two corresponding angles, those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other. That is to say, angle CBA will be equal to angle CED, and both of them are equal to beta. If one of them is equal to beta, then the other one will be also equal to beta because they are equal to each other. So we actually found out that those two angles are equal to each other and they are both equal to alpha, and those two angles are also equal to each other and they are both equal to beta. In the next step we focused on the big triangle ABC, and the small triangle CDE. On those two triangles we know that angle CDE is equal to angle CAB and both angles are equal to alpha. Those two angles are equal to each other and they are both equal to alpha. And we also know that angle CED equals to angle CBA and both angles are equal to beta. This angle CBA is equal to angle CED, and they are both equal to beta. And we also have a common angle, angle C equals to angle C. It is a common angle, it belongs to both to triangle CDE, and angle C also belongs to triangle ABC. So angle C is a common angle, so we can write down that angle C equals to angle C. And we actually proved that all the angles of triangle ABC are equal to all the angles of triangle CDE. Therefore, we proved that the two triangles, triangle ABC is similar to triangle CDE, or the two triangles are similar to each other. Triangle ABC is similar to triangle CDE according to angle similarity rule. The angle similarity rule states that if you prove that all the angles of one triangle are equal to all the angles of the other triangle, then you actually proved that the two triangles similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC is equal to DE over AB. Okay, because of the fact that triangle ABC is similar to triangle CDE, we can write down the following relationship, that CD over AC equals to DE over AB. But what is the value of CD? The value of CD is 2y. And what is the value of AC? The value of AC is CD plus AD. CD plus AD is 2y plus y. That is to say 3y. So CD equals to 2y and AC equals to 3y. And all equal to DE over AB. So here y over y is 1, so y will get cancelled, and we got that DE over AB equals to 2 over 3. We multiplied this equality by AB, and we got that DE equals to 2/3 AB. DE equals to 2/3 AB. Okay, and then we have the last rule. The last rule is true for any triangle. The rule states that in any triangle, the sum of the length of the sum of two sides of the triangle is always will be greater in its size from the length of the third size of the third side, and the difference between two sides of any triangle will be always smaller than the length of the third side. So if we relate to, we have here triangle ABC, we know that the size of AB is A units, the size of AC is B units, and the size of BC is C units. Then the length C will be always smaller than will be always smaller in its size from A plus B. C will be always smaller than A plus B, and C will be always greater than the difference between A and B, or will be always smaller from the absolute value of the difference between A and B. That is to say, C is greater than the absolute value of A minus B, and it is smaller than A plus B. Okay? So we actually can implement this rule in our drawing in triangle ABC. If we relate to side AB of triangle ABC, we can, according to this rule, AB will be always greater than AC, AB will be always smaller than AC plus CB, and it will be always greater than AC minus CB. Okay, AB will be smaller than AC plus CB, and it will be greater. It will be greater than the absolute value of CA minus CB. We know that CA equals to 2 units, CB equals to 8 units. So AC plus CB is 2 plus 8, that is 10. And CA minus CB is 2 minus 8, that is minus 6. And the absolute value of minus 6 is 6, because the absolute value of any number is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. So in total we got that the AB is smaller than 10 and it is greater than 6. But we have already found out that DE equals to 2/3 AB. Okay? So we multiplied this inequality by 2/3 and we got that 2/3 AB equals to 2/3 times 6, and it is smaller than 2/3 times 10. 2/3 AB is actually DE, so we can substitute 2/3 AB by DE. And 2/3 times 6 is 4, and 2/3 times 10 is 6.66. So in total we got that DE is greater than 4, and it is smaller than 6.66. But we also know that DE is a natural number, it belongs to the natural numbers. So we must find out natural numbers that are greater than 4 and smaller than 6.66. We have only two natural numbers that are greater than 4 and smaller than 6.66, that are 5 and 6. So we found out that DE, of the size of DE, is either 5 units or 6 units. Okay? The size of DE, the size of line segment DE, is either 5 units or 6 units. And that is the answer to the question. Okay? Thank you very much.